First adulterant that we are going to crush is paracetamol. So paracetamol is easy to crush because of its soft texture. We need to exchange mortar and pestle for the next adulterant. Our second adulterant is the mint candy. This one is quite challenging because of its solid texture. We cannot crush it easily. After minutes of crushing, this is the final result. is paracetamol with distilled water. Using a dropper, just put amount of water to dissolve your Doterant. In the first 20 seconds of mixing, we observe that paracetamol absorbs the water and its texture is just like a flour. As what I've said earlier, the paracetamol absorbs the water and the texture is still the same. Next is baby powder with distilled water. So as we can see, the baby powder did not absorb the distilled water. Baby powder does not dissolve in water. Instead, it floats on the surface. And last adulterant is the mint candy. As what we observe, the mint candy is like a salt. Still, its texture is just like a salt. Next is we have paracetamol mixed with ethanol. Paracetamol slowly absorbed the ethanol. The ethanol totally dissolved the paracetamol. Second is we have baby powder mixed with ethanol. Within 20 seconds, the ethanol totally dissolved the baby powder. Its texture is just like an adhesive glue. And lastly, we have the mint candy mixed with ethanol. As we can see, ethanol does not dissolve in mint candy. So as we can see, the mint candy is sticking to the surface and still it did not absorb the ethanol.
When snowbird was exposed to the ethanol, it gradually softened. The ethanol seemed to dissolve parts of the candy, changing its texture and possibly its color. The candy's sweet smell was partly replaced by the ethanol smell. The exact changes depended on the things like how strong the ethanol was and how long the candy was exposed. Snowbird candy in water. When snowbird candy was placed in water, it essentially showed no significant change. However, over time, the candy surface began to dissolve, becoming sticky and losing its original shape. The water surrounding the candy became slightly cloudy and sweat tasting. The rate of dissolution depended on water temperature. Warmer water caused faster dissolution. After sufficient period, the candy completely dissolved, leaving only a slightly cloudy, sweet solution.
ethanol based on my observation after 1 minute of mixing it. As we can see in the picture, it becomes absolutely white and no small lumps. It totally melts, and subsequently it is really different from paracetamol with water. Subsequently, based on my observation, the paracetamol with water after 1 minute of mixing it, as we can observe, is not absolutely white. On the other hand, one of my observation is not totally melt.
Upon adding baby powder to ethanol, the powder initially behaves similarly to its reaction with water, floating in the surface and clumping. However, unlike in water, the powder did not readily disperse, even the vigorous stirring. The powder remained largely clumped, with only minimal dispersion into the ethanol. The mixture remained visibly heterogeneous, with distinct powder clumps suspended in the ethanol. After settling, the powder settled to the bottom, showing less tendency to form a uniform suspension compared to water. The ethanol odor remained prominent with little to no noticeable odor change from the baby powder. The observation suggests the ethanol is a less effective dispersing agent for baby powder and than water. When baby powder was added to water, it initially floated on the surface, clumping together slightly. With gentle stirring, the powder gradually dispersed, creating a cloudy and suspension. The suspension remained cloudy even after prolonged stirring. The powder did not fully dissolve. The mixture felt slightly thicker. The plain water, after settling a layer of powder, settled at the bottom of the container. The exact appearance of mixtures depends on the amount of powder and water used as well as the type of baby powder.